carriers look towards putting something into the network, most typically when they look for a bundled solution, a lot of them are off-the-shelf applications. And what I mean by that is an STP has a set of use cases that are pretty much consistent across many networks and many different use cases. However, what we learned over the 20 years of us building this platform called Titan is that there is an element of what I'll call a secret sauce that has to be carried forward. So carrier A's ability to have a use case in their region is going to be different than carrier B's ability to create use cases and value into the carrier space, into their subscriber space. And so we built a very thin, flexible layer of technology that sits on top of every single application. And it doesn't touch anything to do with the core stacks or anything of that nature, but it allows carriers the ability to build real-time use cases that are a little bit outside some of the 3GPP specifications. But it really addresses what they really require, which is bringing some of these historic, custom, homegrown built solutions from a legacy network into a future-proof technology, future-proof platform. And so we've seen tremendous success by offering this service to carriers where they can create their own custom use cases on top of any of the off-the-shelf applications that are seen within the carrier's network. There is multiple ways one can be looked at that, and a lot of that is really, or historically has been driven by some of the advents in cloud services. So when we think about cloud, we think about the ability to interconnect or interoperate with a particular set of elements in a network to something that's not owned by a carrier, so somewhere else. And in order for that to happen, it's almost like the United Nations, where there's multiple languages being spoken, and these languages have to be able to communicate in a very effective manner. And so when you have an open API platform that really opens up a common set of hooks and tools that allows these different elements, whether they be all within a network or they be within a network into a cloud, but they allow these different elements to communicate in a common fashion. And therefore, it helps propel carriers to be able to build some of their own services. And there's multiple ways that vendors give technology to carriers in an open API fashion. Some vendors will give technology to a carrier to just build any service they would like. Some vendors have a hybrid where there is a mix of carrier-built services and vendor-built services. And some vendors provide access to open API technology really to facilitate a very specific goal. Maybe that might be provisioning, for example, from the OSS/BSS layer. So there are multiple layers within an open API platform environment, and not all of them will be required for every single carrier. So having the platform to be flexible in any of those scenarios is really going to be elemental when carriers look at investing into a platform going into the future. So one of the interesting items that we've seen, and if you look about 3 or 4 or 5 years ago, and you look at some of the reports coming out, most of the analysts weren't too sure what was going to happen with SS7 because I don't think the industry quite knew. We saw many carriers looking to decommission SS7 links. We saw many carriers moving towards SIP-based applications. However, really interestingly, within those last 5 years, we've also seen an element of increased mobility, increased authentication, and increased machine-to-machine or IoT type of technology being delivered and deployed and managed by the carriers. The majority of this traffic has been delivered and is continuing to be delivered over the SS7 or 3G networks. And because of that, we are seeing, and Greg alluded to this, an extremely slow sloping of SS7. In fact, we think for the next several years, it's going to continue strong as it's going. And of course, as the advent comes of more 5G phones in the market, additional services in that nature, we'll see that at some point start to pivot. But that pivot is slow. And so from our observation point, we couldn't be happier because of the way we built the platform, we are, and that platform being all G, so it has to handle everything from 2G through to 4G to VoLTE to 5G and to the next G. We inherently have to go build future services, future features, and better performance in any of our SS7 applications on that platform. So we see a great demand for SS7 applications, especially on the STP side, in almost every single region that we're doing business in. Yeah, it certainly is a mixed picture. Like, for example, in Europe, with some of the recent changes in the last couple of years about roaming, we see a really big spike in SS7 roaming traffic. Whereas other regions of the world, we don't see so much as a spike, but a continued usage of the existing networks. And so there really is a bit of a difference regionally, but I think there is a common thread, which is it is still being used. The SS7 network is still being used and relied upon quite heavily. And those are bringing in very important revenue streams into the carriers, which they do not want to jeopardize in any way. So let's take an example of a typical network 20 years ago. So 20 years ago, carriers would deploy a box, and that box would have a database, and that box would have physical connections into it with limitations at some point of traffic and capacity. And in order for carriers to get to scale and get to carrier grade readiness and failover, they would deploy dozens, hundreds, or thousands of these boxes across a global network. How did these boxes talk to each other? It was extremely difficult. It was almost like a leapfrog, where if a request came into the network, into the signaling core, that particular element may have to go check 10, 15, even up to 20 different other boxes or other elements in the network in order to get a piece of data to make a routing decision. That in itself is an extremely inefficient manner of handling signaling within a core network. However, because subscribers didn't really roam that much 20 years ago, the advent of the mobile phone was limited in some regards from an application perspective 20 years ago. Uh, Carriers built those networks, and it was really a strong network to handle what the industry was, what the demands of the consumers were at that time. Fast forward over 20 years, where the device became a crucial tool for business. It became web-based, it became application dependent, became bandwidth heavy, that the old way of signaling was an extremely inefficient way to get data across the network, and in a very inefficient way to protect the network given all the different moving parts. And so technology over the last 20 years has allowed carriers to move away from those efficiencies by a platform approach like Titan, where we consolidate into one common view all data. So when an element comes in, when a request comes into the network and signaling has to take place, it needs to go to just one location, not 20 locations. Or it can go in through one protocol and go out a different protocol. So there's an inherent intermediary interworking function that doesn't prevent these two networks from not talking, like Diameter and SS7, for example. And that's just the application side, I mean the core network applications. Now think about the architecture side. We went from very large, I'm sure many people on the call remember these huge devices that were deployed into racks that might take up half a rack or a full rack, towards something that is a small compute the size of a laptop that can handle signaling. If you look at some of the services that NetNumber offers in our private LTE space, we can miniaturize an entire LTE core into the size of a backpack. And so now you have a different way you build your architecture out, which is saving energy costs. So it becomes very friendly towards the environment, and it becomes less expensive to run because you can do more, a lot more and a lot less. And so we see great strides in the last 20 years of technology that really, it really is an about face when we look at how signaling was managed 20 years ago.